In number 1, we have a linear inequality, and we're going to solve for x, and we have to divide both sides by -5. And now we remember the rule that when we divide both sides of an inequality by a negative, we change the direction of the inequality symbol. All right, so that here we have x is greater than -3. And we continue to solve number 2 in a similar way to the way we solve linear equations. We just first simplify this right-hand side over here, and we're going to open up parentheses, multiplying through by -7. So that would be -7, and here we'd have plus 28x. Okay, so like terms, 2 minus 7, that's -5 plus 28x. And now we can work with both sides. Let's add 2x to both sides, gathering together the x terms. So we have 3 less than -5 plus 30x. And now add 5. And we have 30x greater than 8. And now we'll divide by 30. So we have x greater than 8 over 30, or divide top and bottom by 2, and we have 4 over 15. Now notice it says x greater than 4 over 15, but we'd like to write that with x on the left because that's more standard. So let's do that. So we have x, and then we have 4 over 15, and this has to read the same way, greater than, x greater than. So what we did here was we didn't just switch the inequality, we wrote the whole thing in the opposite direction. All right, I consider this written backwards, we wrote it forwards. In number 3, we have some denominators that we want to clear out. We have a 5, a 3, and a 15. So we're going to multiply both sides at something that all three go into. So that would be 15. We're just going to multiply both sides by 15 over 1. And here as well, 15 over 1. All right, on the left, we divide 5 into 15. We have 3. 3 times 3x plus 1, less than. And now on the right, let's multiply through. I'm going to first just distribute the 15 over 1. Okay, so here we get 1. Here divide 3 into 15, we have a 5. Okay, so now let's rewrite. On this side, we'll multiply through by 3, so we have 9x plus 3. Here we're going to multiply the 2x minus 1 by 5, so that would be 10x minus 5, and here we have a plus 1. All right, let's combine these two like terms on the right, so that would be 10x minus 4, and here we have 9x plus 3. All right, let's say we subtract 10x from both sides. Here we have minus x plus 3, less than -4, and continue solving by subtracting 3. Negative x less than -7, and now we're going to divide both sides by -1, and that would switch the direction, dividing by negative. So we have here x greater than 7. In number 4, we have 5x minus 2 greater than 13, or 3 times 1 minus 2x greater than 1. So we're going to solve each separately. All right, so let's do that, and then we'll put them together with an or. So here we'll add 2 to both sides, start solving. 5x greater than 15, and we have x greater than 3. And here multiply by 3. 3 minus 6x greater than 1. We'll subtract 3. Minus 6x greater than minus 2. And now we're dividing by a negative, so we switch direction. And we have x less than 1/3. And we have an or connecting these two. X greater than 3 or x less than 1/3. Let's draw this on the number line. All right, here's, let's say 3, and let's say this is 1/3. So that means x can be here, or x can be here, less than 1/3. All right. Number 5 again, two inequalities connected by an or, and we'll just solve them separately. Okay, let's subtract x from both sides. And we have 2x plus 1 less than 7. Subtract 1. 2x less than 6. And then divide by 2. X less than 3. And here we'll subtract x. 3x plus 2 greater than 17. Subtract 2. 3x greater than 15, and divide by 3. And we have x greater than 5. And these are connected with an or. So this says x greater, let's put 3 and 5 on the number line. Let's say this is 3, this is 5. X less than 3, that's here. I'll put a round bracket there, and x greater than 5, that's here. Also, that gets a round bracket to indicate that 3 is not included, 5 is not included. Here we have two inequalities connected by an and. So let's start by solving them separately. Sorry, that's 5 plus 3x less than 5x plus 1. All right, so let's say we subtract 5x from both sides. Here we have 5 minus 2x less than 1. Subtract 5. Minus 2x less than minus 4. And now we divide by minus 2, and the direction changes. So here we have x greater than 2. All right, the next one, here we have 5x plus 2 less than or equal to 32 plus 2x. Let's subtract 2x. And we have 3x plus 2 less than or equal to 32. Subtract 2. 3x less than or equal to 30. And we have x less than or equal to 10. So this is x greater than 2 and x less than or equal to 10. We can write this more compactly by putting x in the middle and writing less than or equal to 10 on the right and x greater than 2 on the left. This is called a double inequality, always implies that we have an and. We can't write a double inequality for an or. This means x less than or equal to 10 and x greater than 2. All right, let's just do the number line here. Like we did before, we would put 2 on the number line and 10 on the number line, and x is between 2 and 10. So we would shade in the part of the number line between 2 and 10. And now how about the brackets? X greater than 2, that gets a round bracket. And x less than or equal to 10, that gets a square to indicate that 10 is included. In number 7, we have a double inequality. Let me rewrite it over here. 2 minus x over 3 in the middle, and we have a 2 in the minus 5. Okay, so this means that this expression is less than or equal to 2 and greater than or equal to minus 5. So first we want to get rid of the 3 in the denominator, so we're going to multiply all three sides by 3. So we're going to multiply this by 3, and here, and here. Okay, so here on the left we have minus 15. Here, multiply 3, we get 2 times 3 is 6, minus, and when we multiply the next term, we would just get, those 3's would cancel, and we would just get x. Okay, so we multiplied through by 3, we got 6, and then just x. And on the right, 2 times 3, we have 6. All right, we want to isolate x in the middle, so let's get rid of this 6. Let's subtract it. So here we have minus x in the middle. Here we have 0. And here we have minus 15 minus 6, that's negative 21. And now we want x in the middle, not minus x, so we're going to divide all three sides by minus 1. Dividing by a negative switches the direction. So we get x in the middle, and here we have greater than or equal to minus 1, and here we have less than or equal to 21. So this is a double inequality, but we consider it written backwards because we like to have the smaller number on the left and the bigger on the right, and here this is in the opposite order. So let's switch it. Let's put the minus 1 here and the 21 here and the x in the middle and rewrite it so it reads the same. It has to read greater than or equal to minus 1. Okay, that says x greater than or equal to minus 1, and has to read less than or equal to 21. Okay, so in effect what we did was we had something that was written backwards and we wrote it forwards. In number 8, we have to recall a little rule that says that if 1 over n is less than 0, okay, then that is true if and only if n is less than 0. So we have, for example, let's put in some numbers like 1 over minus 2 is less than 0 because minus 2 is less than 0. Okay, if this were positive, then this would not be negative. So in this expression over here, we have 1 over 3x minus 7 less than 0. So that implies that 3x minus 7 must be less than 0. So we can solve this. All right, so let's do that. So we have 3x, add 7 to both sides, is less than 7, and x is less than 7 over 3.